Welcome to this explainer. Okay, let's just dive right in. Today, we're exploring one of the absolute most captivating alternate history scenarios you could possibly imagine. We are going to completely rewrite the history books and look at exactly how human civilization would have developed if dinosaurs never went extinct. I mean, forget the asteroid, right? Forget the millions of years of separation. We are looking at a world where humanity evolved right alongside the ultimate apex predators. So what if the asteroid actually missed? Imagine for a second what our world would look like if early humans literally had to share the planet with giant, terrifying prehistoric beasts. We normally think of human history as this huge struggle against the elements, against disease, against each other. But if that asteroid missed 66 million years ago, our ancestors would have stepped out of their caves into a world already ruled by absolute titans. How would we build? How would we farm? Or honestly, how would we even survive?
Well, to wrap our heads around this, we're going to follow this timeline of coexistence. We'll start way back in 10,000 BCE in the Stone Age, jump to 1200 CE in the Medieval Age, check out 1850 CE during the Victorian Age, see where we'd be in 2026 CE for the present day, and finally look ahead to 2100 CE and the future. It is a completely wild ride from vulnerable prey to masters of genetics, so let's get into it.
Section 1. The Stone Age. Survival and Strategy.
So looking at Stone Age survival tactics, our ancestors survived not through speed or physical strength, but by just pure, unmatched resourcefulness. Think about it. A single human going toe-to-toe with a massive theropod? Yeah, no way. So survival meant intense teamwork to avoid giant predators altogether. But we didn't just hide, right? We adapted. We hunted smaller dinosaur species for food. We actually used their massive bones, which would have been stronger than pretty much anything else around, to engineer our very first tools, weapons, and even the frameworks for our shelters. We turned those thick dinosaur hides into heavy-duty protective clothing, and foraging their giant eggs provided this dense, absolutely crucial source of calories. So, early human civilizations wouldn't have just been shaped by rivers or the climate, but by the migration patterns of massive dinosaur herds.
Moving on to Section 2, the Medieval Age, Beasts of War.
Okay, picture this in your head. Massive armored triceratops charging straight at fortified stone castles. These are your heavy armor herbivores. Now in peacetime, these guys would have revolutionized agriculture, right? Plowing massive fields in a fraction of the time, hauling incredibly heavy stone blocks to build cathedrals. But in wartime, they become living siege engines. Contrast that with the fast scout predators. Think of light cavalry, but terrifyingly fast and utterly lethal, used to deliver messages and execute quick tactical strikes. Kings and generals would have strategically bred these lineages exactly the way they bred warhorses. It's a total game changer for medieval warfare.
But here is the really crucial point. Even with fearsome living weapons on the battlefield, human tactics, engineering, and leadership determine the outcome of wars, not just giant beasts. You might think, oh, whoever has the biggest T-Rex automatically wins, but honestly, that's just not how human history works. Castle walls would be specifically engineered to withstand a dinosaur siege. Defenses would rely on massive moats and clever traps. At the end of the day, human intellect and cunning strategy still decided the victors. The beast was just another tool in our arsenal.
All right, Section 3. The Victorian Age, Wonder and Prestige.
This era marks a completely incredible societal pivot. Quote, "For the first time, dinosaurs would be viewed less as tools and more as attractions and subjects of scientific study." See, thanks to the Industrial Revolution and steam power, we simply didn't need a massive herbivore to pull a plow anymore. We had machines for that now. So literally overnight, these creatures transformed from essential beasts of burden into objects of pure wonder, prestige, and academic obsession. The Victorian dinosaur craze was a real thing. Society just became completely obsessed. You'd have these super wealthy individuals showing off by building private dinosaur parks right on their estates. Imagine attending a high society tea party with a Brachiosaurus just casually grazing in the background. You'd see traveling exhibitions bringing rare species straight into the heart of London or New York, drawing these massive, amazed crowds. Scientists were frantically studying their biology. Newspapers were selling out daily just by putting a weird, newly discovered species on the front page. They absolutely permeated every single aspect of Victorian art and literature. Which brings us to Section 4, Present and Future, Protection and Genetics. Now, fast forward to today, our modern management of dinosaurs would look surprisingly mundane. We'd be using advanced GPS tracking, specialized zoos, and strict laws to monitor wild populations, much like we treat elephants or whales today. It definitely wouldn't be some wild free-for-all.
Tourists would visit highly secure national reserves, governments would use satellite surveillance and drone tech to track a wild T-Rex, just like we track endangered rhinos. There'd be international laws, massive zoo enclosures with specialized vets, and huge public campaigns to save their habitats. They would honestly just be a normal, albeit very large, part of our everyday natural world.
But let's look at the future of dinosaur science, because this is where things get truly insane. Step 1, as our genetic mastery peaks, we study dinosaur genetics to develop revolutionary new medicines, tapping into their robust, ancient immune systems. Step 2, we improve global agriculture through that advanced biological research. Step 3, we actually start genetically modifying species to assist in large-scale environmental restoration, like bioengineering herbivores to rapidly reseed deforested areas. And Step 4, we literally engineer specialized, radiation-resistant, low-oxygen dinosaurs for space exploration to help build colonies on Mars. Just mind-blowing stuff.
But, and this is a big but, should dinosaurs be genetically modified purely for human benefit? Having this kind of godlike power forces us to confront some massive ethical dilemmas. Just because we have the tech to harvest their cells for medicine or bioengineer a space dino, does that actually mean we should do it? The debate over how much control we should exert over these living, breathing titans wouldn't just be a footnote. It would absolutely become one of the biggest, most fascinating moral debates of our entire era.
And finally, Section 5, Humanity's Strength, Our Ultimate Superpower. All of this alternate history brings us to this definition of true strength. It's not immense size or physical power, but rather the unmatched human ability to think, learn, create, cooperate, and adapt. If dinosaurs were still alive, they'd for sure be the most powerful animals physically, but they wouldn't be running the planet. Humanity's superpower was never about being the strongest. We went from hiding in caves to riding them into battle to mapping their DNA. Our unique, incredible intelligence is what truly shapes the world.
Which leaves us with this final, thrilling question. If human intellect can tame dinosaurs, what impossible challenge will we master next? If we have the adaptability to tame giant prehistoric beasts and integrate them into every single level of our civilization, what incredible frontiers are we destined to conquer next? Curing disease? Reversing climate change? Exploring the stars? Our history shows us that literally no challenge is too big. Thanks so much for joining me on this explainer, and I will catch you on the next one.